We'll continue with Tonny Brink from the Danish Test and Resource Center for Small Wind Turbines. Please, Tonny, take over.
Thank you, Morten.
Oh, sorry.
Are we ready, Daniel? What? Almost, yeah. We just have to change. Yeah, well, I'll just start off by talking, Daniel, and then you'll come on with the slides. Welcome, everybody, and glad that we can be together in this webinar now that we cannot be together in person. Of course, we planned this event on this date due to the Wind Fair in Hamburg, where we could have joined up and went to see the fair after this seminar. That was actually the first approach, was to place it as close to the Wind Fair in Hamburg as possible, for people who only had to fly into Europe one time. But now that that is not the case, and we have to settle for second best instead of being able to network in person, then we'll try to go on with the event as a webinar. Yes, and I think most of you know that we are at Nordic Folkecenter, and the reason why I'm bringing this is also that we are a big part of the Nordic Folkecenter. Actually, it's called Nordic Folkecenter that pays the salary for all the employees at the test site, so we're very much connected. And at the same time, we also taking a great advantage of being in an NGO, because being together with an NGO gives us a lot of opportunities for the green transition, as wind power, and especially small wind, is really very much needing the NGOs and the grassroots in order to still be on board wind at all. If we are not having the grassroots, we will totally be left in the dark. So we are really much depending on Green Deal in Europe and grassroots movements, prosumer movements, in order to be able to produce your own energy in the rural area in particular, but your own energy in general, whereas the cities mostly go for PV. And then, of course, we have a lot of visitors at Nordic Folkecenter that also visit the test site at the same time. Unfortunately, yes, Daniel? Unfortunately, our new test site, we have two green spots, which is actually our old test site and our new test site, which is 40 kilometers from here. And we would have hoped we could have had it here in the very best of the wind regime in Denmark, but we couldn't find a spot together with the municipality. But we're still in a very, very good region. These two red dots are the national test centers for big wind, where we have Østerild and Offshore, which are national test center operated by DTU, which is also one of our collaborators. We have a steering group for our new test facilities, where we have DTU represented with Peter Hauger Madsen as a part of the steering group, and we have Aalborg University with Florence, and then we have the energy movement with House of Energy that has moved into Energy Cluster Denmark, which is also represented in our steering group, together with a lot of our very old and traditional networking partners, which is, of course, is the Blacksmith organization in Denmark, which is today part of Technique and yeah, just next slide. But we have the same business model as we always had. We would like to welcome everybody, so we work with all kinds of renewable energy in general, but in this session we'll only concentrate on wind, but we started out actually with thermal solar in the very early 70s, and then wind came along, and we still try to commercialize small wind. And our business model is therefore widespread into varying from a complete deal where we make the agreement with the certifying body, and we take the contract to the certifying body, and unfortunately we cannot do it ourselves. But one of the reasons for that is also that it's so individual what kind of certification the consumer need or the manufacturer need, whether it's an MCS approval or IEC standard he's signing up against. So therefore we have these different approaches where varying from paid by the hour to only renting out a foundation where the manufacturer can put up a wind turbine. Yeah, next time. Then we have the benefit of being an NGO, therefore we can participate in standardization work for free. Otherwise, it's rather expensive to be on board in these kind of committees. But they allow NGOs to be on board because they would like to have an opinion in the work from an NGO as well. And we are part of S588, which is headed by Peter Hauge Madsen, also from DTU, and they are part in the bigger term on TC88. And TC88, we have Jerome Van Dam from the American side to head that one. Then there's not so much to say about that. I think Mike Berge mentioned a lot about it in his presentation, so we can watch his presentation as well. Those who were not present during his presentation, where he was talking a lot about distributed wind in general. And we're leaning very much up against distributed wind. What is new is that IEC RE, where we take out the conformity standard, the -22 out of 61400-22 is being taken out of the design standard and moved into an operational document in IRC RE. So all the approval processes for renewable energy will in the future end up in the IEC RE. Next, Daniel. Then this page here says a lot about how over-regulated, you could say, is small wind in Denmark. And unfortunately, a lot of countries copy Denmark in legislation. So therefore, some of it is out from international standards, and other things are Danish rules that we struggle with here at the test site and as a Danish manufacturer. And if we go through them, then we have turbines up to 5 meters where in swept area. And it's just according to the standard that they are very easy to approach. And we see in the new green deals in Europe that there could be a market for manufacturers due to that you have in the RFG rule set for generators, there is a limitation where up to 800 watt is not, you don't need any, it's not part of the technical requirements. So therefore we see that hopefully there'll be some manufacturers that will change that market in order to have some fine products for that range of turbine. Then in Denmark we have had a long history in having a 40 square meter rule that allowed entrepreneurs to get into the wind industry on easy terms. We basically took the design criteria from the turbines in the 80s, and you made a very, very over-designed or over-calculated wind turbine. And as we see, the Danish turbines from the 80s, they are still running on the 40 years of operation. So, and if we go down to the XBlade that recalculated the blade from our 84 model of turbine, then they expect to have a 60-year lifetime. So they're really, really over-designed. And but then we have the small wind standardization is stopping at 200 meters square rotor size. But the funny thing is that we have this new RFG rules, which have been increased to embrace 125 kilowatt. And it used to be 50 from the solar, from the PV systems, but now it's been lifted up to 125. And it opens up a new size of wind turbines within the Class A segment for generator rules. But still, there we are challenged a little bit with the design standard, because 200 square meter rotor size is the same as an old 55 kilowatt Vestas machine or commercial machine. And even a 55 kilowatt machine in the modern market today would probably have a 400 square meter rotor if it should be really attractive for low wind. And so therefore 125 would be at least 400, 500 meter square. So there we might have to get some help from the American side. They have already left out the meter square in their approval and are going for 150 kilowatt, like Mike Berge explained. Here in Europe, we go for 125. That's okay with us. It's a start. But we challenge with the 200 meter square, because it will give an even funnier size turbine. Then we have a limitation for small wind in Denmark, or household wind turbines as we prefer to call them. That is the 25 meter height limit to blade tip. And these two of these criteria really give problems for consumers, because that means that all turbines will stand in a turbulent environment. Instead of putting them in an open field where they're suited the best and have the less turbulent winds, then we place them just right next to our buildings and only 25 meters away from our buildings, and the maximum height of 25 meters. So we're sure to be behind some kind of object that create turbulence. Then we have the maximum limitation of generator size, which is already in the early days. It was also a funny creation of generators, because, as I told earlier, the 200 meter square was originally a 55 kilowatt machine, but here it was downsized to 25. Today, with the harvesting wind from the low wind sector, then that's okay. Then, of course, it should be in your own meter traction. Yeah, you can say that's fair enough that you could be behind the meter. I don't have so much to say about that. I added point 8 with the noise regulation, because I think it's important that we look into this noise regulation, because this noise regulation is also the main reason for small wind and big wind to be in conflict in Denmark. Because whenever you put up or you want to put up, or the municipality want to find a location for big wind turbines, then they beforehand leave out small wind, because they've been taken into the total noise impact level for the entire wind park. So if there's a small wind park within the range of the big wind farm, then the noise emission report is increased, and then they cannot put up this wind park. So therefore, the municipality go out beforehand and say, okay, you cannot put up a small wind. And therefore, if this noise were, because at the same time, you're actually allowed to have a heat pump standing, making all that, the kind of noise that they make, you only apply to fulfill the noise relation towards your neighbor. That means that you're on the edge of your entry to your neighbor. You measure the noise level, and if you don't over exceed that, then it's okay. And so therefore, why are the small wind turbines not a household energy installation that doesn't inflict on the big wind? We try to work for that from the NGO side as a criterion. Then what new is that from year end this year, our old 40 square meter rule is expiring, and it's, from our point of view, it's really a shame, because it was a very neat entry for entrepreneurs to be on board in wind, and a lot of our entrepreneurs came in that way and are still on board. Then they have come up with the latest issue is they want to make a guideline for this new legislation that covers small wind. And the bad thing is that personally I'm against these kind of guidelines, because a guideline was the reason for having this 25-meter distance to buildings, due to that one municipality found that they had a guideline explaining that we have a distance from 25 meters. Near buildings means you're 25 meters to buildings. They had a guideline saying that. And then the other 98 municipalities, they basically inherited that guideline. And then that guideline became a rule instead of just being a guideline. And I fear the same will happen with the standard, with the legislation. When you have a guideline, you mention things in that guideline as a help, but all of a sudden it's also written into the law instead of. So that's the reason why I'm against this kind of guidelines. I would prefer just to have the law, and then you can interpret and read that law the way it's meant to. Thank you, Danish. So that was a little bit, that's just explaining that we still have Plan B, where we have room for some medium wind before we go to big wind farms. So there is distributed wind up to 3 megawatts that is stored in this sentence here. But also again, the 0.8 kilowatt. Yes. Then back to our installations here at Folkecenter and how we play around with things to try to both motivate and encourage people to be on board in renewables. So this is a project installation of an offshore floating foundation with a small wind, where they have made the blade themselves from actually Hugh Pickard fixture on how to design the blade. But as we discussed the other day with the Hugh Pickard setup, allows young entrepreneurs to go through the entire spectrum of designing a wind turbine, understanding. We use it a lot to make them understand fluid dynamics and aerodynamics in general. So yeah. And then we have we of course have had a lot of these small wind turbines that are delivered in a box that are very attractive to a lot of people that want to buy them online and install this as their own wind installation. And some of them can actually generate a lot of energy, seen from and are very successful in the marine sector. But in the marine or in the sailboat, especially in the sailboat sector, they're popular when you cruise the world. But they're forgetting that a sailboat very often have 70 to 80 square meter sail. So it's actually the 70 and 80 meters square of sail that drives the speed of the boat, and at the same time drives the turbine. So therefore it generates energy. But when they come to a wind sector that we saw yesterday from Greenland, they won't produce any energy. Yeah, next. And here's another variant of it. It's leading edge 600 that we play with on the test field together with a Norwegian guy that is selling these for cabin installation in the northern part of Norway. And but it is just the kind of kit that attracts Mr. and Mrs. Denmark. But they end up having an installation that you could say 3,000 euro for leading at 600. You add some power electronics, you add a tower, so you're easily in 5,000, 6,000 euro before you have an installation running. And at 300 kilowatt per hour, 300 kilowatt hour per year, at 2 Danish kroner per you have a payback time of 100 years. So it's not you don't do it from economical interest. You do it out from heart that you want to have a wind turbine. But the problem is that also the turbine we saw, if you leave out the dump load controller and just go directly, in some case, into an inverter or into a very, very simple wind inverter that just short circuit the generators, then you can be very sure if you have a high wind season and you produce a lot of energy, and all of a sudden you want to stop the turbine because now it's too much, and therefore it short circuits the generator and breaks it down. But then the excess heat from the generator will burn the generator. So Mrs. and Mrs. Denmark's turbine is dead at that point. So very, very vital thing is a dump load control. Yes, Danny? And a very, very simple, you also need to find a simple way to address people with a locking system, because even if it's cheap installation, they think they still want that app. So you're not getting around having an app or having some kind of SCADA system that will show them something. Next thing. Then yesterday we were also through Upigiat, and of course we have a Upigiat turbine here at Folkecenter, being an NGO. So Hugh himself were here building it with us years back, and now we're thinking of moving it to our latest development, which is an organic tiny house we built, and there we need an electric installation in that building as well. So we have just renovated one of our old electric cars, and we'll equip that with new batteries, and then that will be the vehicle to grid in the tiny house. But we tried on several occasions to play with the vehicle to grid. I think Ango will tell a little bit more about it, because he played along with Tesla and other installations where you use behind the meter installations to harvest energy for vehicles. But one of the problems that was also mentioned yesterday is this fact that it's very, very difficult to get access to the protocols for controlling the chargers to get that from the car manufacturers. And then we have the entire all the rules from the building regulations regarding batteries. That's still very, very new to a lot of people. That people who work with lead acid batteries, they know for sure that they have been used to, especially in the marine sector, that you had special rooms to make sure you didn't have acids come building up for having an explosion. So you had fireproof rooms. But having a lithium battery today will also require a burn-safe room, and that has far from been taken into the building regulations so far. So we still have a lot of work ahead of us on building regulations and batteries. Then next. And of course we have it where we have batteries inside the building from our old installation, where there wasn't thought of then of course we have our old 40 square meter household turbine from the 90s, and we use it generally for scale up test, and it's become more and more attractive, especially to universities, because they all realize that they want to make a new material surface or something on an offshore turbine. But when they build their business case and they find out what it costs to go offshore and test on a real offshore turbine, then they all of a sudden want to make a scale-up test. And there we very much use our 40 square meter wind turbine, because if it's on a really, really good position, then 40 meters square is 1,000 kilowatt hours per year per square meter. So if it's on a really, really good position, then a household turbine with a 40 square meter rotor can produce 40,000 kilowatt hours on the best location in our region. Tri-blade, as we see here on our old 75 kilowatt Flashmid turbine, they started out having a scale test on the 40 square meter. Then they scaled up for 100 square meter, for 100 kilowatt on our 75 kilowatt turbine, with a close to a 400 square meter rotor. And and now they want to go for an even bigger turbine. So there we'll either have to go out and see if we can make arrangement with the turbine owner, or they'll do it directly. We haven't decided on that, but they are aiming for a megawatt installation now. Next time. Then we have a tandem win on our test site at the moment. Otto that gave a presentation of his product yesterday, so you can find this presentation among the presentations if you So I won't say any more about that one. Then I'll move to our test site in the north. On our new test site, we have a 15 kilowatt prototype with the new blade design from Olsen running, and they are on a new tower design where they have made cost reduction on the tower, using the same kind of tower that you use for a lot of the radio towers. So it's basically this design from a radio tower that's been brought into small wind. And then the most interesting thing is that it's running in parallel with the 72 kilowatt hour lithium battery. So a 15 kilowatt turbine, a 14 kilowatt dump load, and 2.5 kilowatt PV, and then 72. But I think Anga will come in on that a little more, so I won't take the presentation. Next. Then we have an XBlade, a 200 square meter XBlade from the joint rotor blades that we're testing on an old Vestas machine. We are basically almost finished that test for them. We just need to make a noise measurement report. That's the only thing left to fulfill in from our side. Next. Then we have a Viking Win variable speed that stands in and runs for certification and MTS certification. And at the same time, when they're at the test site, when they're finished with this certification, they will continue at the test site and try some other new design features. They want to test another rotor maybe, or some new tests. Yeah. And this is all about why we can't say so much about the production data on neither the XBlade and the TriBlade from Lund University, is that they actually own the data. So we are only helping them to make the reports and get the work done on collecting all the data and all the measurement reports. But it's their data, so we cannot reveal their secrets. So I would have loved to have shown you all the CP factors on both the TriBlade and the XBlade, because we'll get a lot of questions from all over the world whether we could reveal what have they achieved in CP on the XBlade at the moment. But I think they're doing quite good. So, but and you can visit their own homepage on TriBlade and on joint rotor blade to see what they're revealing there. And then we of course have a mobile solution. We would love to have all turbines on our test site, but sometimes it's too crowded that we don't have an available foundation. So it could be to go to a manufacturer's location and do the measurement and the mobile installation. Also to bring costs down, because of course we're interested in keeping the cost as low as possible, because certification is expensive. If we're talking about certifying a small wind MCS standard, we're talking about 100,000 euros. So it's really expensive. And as Mike explained the other day, then you say you have one MCS approval for Japan or covering US, England, and Japan. No, it only covers UK, and then you can start over again paying another 100,000 euros to get one for Japan. And yes, next. Incoming projects. This is what Windhouse just has revealed lately, is that we have had this turbine in operation at our test site. They're bringing in, they're manufacturing a new model here in Denmark at the moment, and hopefully we'll be chosen to test that one. I think we will, but then we have our old wave test station. We have something coming in on wind on the wave test station. It's a scale-up test on some offshore installations that we hopefully will be a part of. It's too early to say so much about it, but we're very interested in getting a project like that. Also, due to that, we have the wave test station in our facility. So, yep. Next. Yeah, and then Anke would say something about positive list and all about how can we operate behind the meter, and I'll leave that up to Anke. And next, and Daniel will come after Anke and say something about the work we do with tomorrow. Okay, tomorrow Daniel will take us through our old catalog. People are really requesting and have been doing it the whole period and say, when are you coming with a new release? And we say, we come with a new release next year, but we've been saying that for 4 years now, so we can't postpone it anymore. So we are taking a different approach, but Daniel will present that tomorrow. Next. And then you can find at least mine and my colleagues' contact on the homepage for the small test site. So I think that was it for me for today. So, and of course, I'm open to questions, or should we take them joint, Anke? Or should we take the questions afterwards, Daniel? Because Anke might cover some of the questions. Yeah, I think so. But I'm in the room, whatever kind of questions you may have.
Yes, thank you very much, Tonny. I said before, if you have any questions or comments, we'll take them afterward.